Hello, everyone. Thank you so much for joining us today for this webinar presenting ArcGIS Online Best Practices for Hosted Feature Layers. I'm Marianne Ferretta, a product manager on the ArcGIS Online team, and I'm pleased to introduce you to my teammates and today's presenters, Jeremy Bartley, Paul Barker, and Chris Whitmore, who together have over 30 years experience engineering and architecting the UX and APIs which drive the functionality we're examining today. Before we begin, a couple of important points to share with you. First, this session is being recorded and will be sent to you via email in the next couple of weeks. And second, if you have questions during the presentation, please type them into the chat window and our panel will address them at the end of the presentation. Thank you again for joining us. We're happy to present ArcGIS Online Best Practices for working with hosted feature layers. Jeremy?
Thanks, Marianne. Okay, let's get going here. With ArcGIS Online feature data, you can manage your data efficiently and easily. It's open. You can work with GeoJSON, spreadsheets, other common geospatial data formats, photos with locations. It's updatable, so you can update that data interactively or through efficient bulk updates. Chris will show an example of bulk update later. You could do that from the field, like with Collector or Survey 123, or directly from your browser. You can create powerful data-driven visualization. These data-driven visualizations are designed to support dynamic information products like with story maps, dashboards, and so on. It's very performant, powered by dynamic feature tiles, which combines the best of vector tiles and updatable data. What's cool about that is that the feature tiles, they really represent your data. So as your data changes, the visualizations are up to date automatically without you having to manage anything. Within ArcGIS Online, we leverage cloud-native technology, and we have a cloud-optimized implementation. It's highly performant and supports viral load. During peak COVID dashboard time back in March and April, I mean, we were seeing queries of upwards of 170,000 queries per second on ArcGIS Online. So it's definitely can support that viral load. Powers the WebGIS model while also delivering data in open standards. Supports many publishing and data update options. Can be used offline and also supports collaboration with your portal. And you can even scale up if you've got heavy database operations that or heavy queries that you want to run against your analytical data. You can upgrade to premium data stores for more performance. Really, that feature layer represents your data. That's really the jumping off point for other types of visualization layers to be used in maps, to be shared in information products. So the feature layer, from it, you can create other feature layer views, tailored views into your data set without duplicating the data. Paul will talk about that. You can also create raster tile layers, scene layers from your feature layer. A scene layer is an optimized 3D layer for use in 3D scenes. You can also deliver the data through WFS. And later this year, you'll be able to deliver it using the OGC API for features. That's the next generation feature endpoint for OGC. And also later this year, you'll be able to create vector tiles from that one feature layer. So there's lots of different layers that you could work with, but it's important to note that with the feature layer, you can really get amazing performance and flexibility and to be able to easily maintain your data and keep those visualizations up to date. So you can do a lot with just the feature layer. Let's drill into kind of what happens behind the scenes to make those feature layers performant. Over the last few years, we've been moving all of our web applications to use WebGL. So WebGL is essentially instructions that you're pushing to the graphics card to be able to render things in the most optimal way. So it supports fast rendering. It's a modern web experience, and it does allow you to bring in way more features than you used to be able to. Also deliver data in protocol buffer format. That's a binary format optimized for delivering data. It results in a smaller payload that then you have to download from the server. And we make heavy use of response caching at multiple tiers. And really what that means is it gives faster queries for everyone. Kind of walk through this diagram. You can see that to talk about how response caching works for public layers versus private layers. On a public layer, it's going to request the data it needs for that particular tile by querying the server. First off, it'll check the browser cache. Does the browser have the latest data? If so, it'll use that. It'll see if it's also up to date. If that's not there, then it'll pull from the CDN. CDN stands for Content Delivery Network. You can think of these as just many numerous nodes throughout the world so that you're going the shortest physical distance from your browser to one of those nodes based on where you are in the world. If it's not there, it goes to ArcGIS Online. ArcGIS Online has its own cache, this feature tile cache. And it will check and see if what it has in this feature tile cache is up to date. If that's not there or it's not up to date, then it'll go and actually execute the query on the database. Once that query is resolved, the feature tile cache gets updated. The CDN will now have a version of this request in its cache, and the person's browser cache will also have it. So that the next time you visit it, you might pull directly from your browser cache, or if somebody else on a different browser on a different machine were to come in, they might get it from the CDN. And that's going to give you the most optimal performance. I'll show a couple of examples of that in the demo. For private layer, it's basically the same, except that we don't use the CDN for your private data. It's always going to go back to ArcGIS Online. So a little bit more about feature tiles. This is meant to give you a sort of under the hood feel for what's happening, to give you confidence in knowing that when using the ArcGIS Online platform, you are getting the best possible technology, and that it can be performant and scale to very, very large loads. So this section is going to sort of drill into that and give you an idea for how we do that. Let's take this example here. I've got building footprints across the New York region. There's actually 941,000 polygons drawn in this application. Well, how did all that data get there, and how did it get there in an efficient way? Well, it actually queried for data one tile at a time. So you see all these white boxes. This is where we are querying data from the server. We're using the same envelope for each of those queries so that it's repeatable. Now, some important points to call out for what comes back, or sorry, how we're requesting the data. We're requesting with an envelope. We're just requesting the fields that are needed for the display. We are quantizing or generalizing the data so that we get no more than one vertex per pixel. And in this view here, that's 38.21 meters. And we're telling the server that this is a tile request and it can cache it. When it returns, there's a lot of good stuff here. I see data coming over HTTP2, over HTTPS. I see the times are low, and the cache, I see that in this case I'm getting a hit from CloudFront, that's our CDN, and also that it's got feature tile cache within ArcGIS Online as well. We also try to minimize the amount of data to make it the most efficient way possible to read that data and push it to the graphics card. So just to give you an idea, this isn't, you don't need to remember this or anything, but just to give you an idea, we are just returning for, like, let's say a polygon. We're returning the first point in a ring, and then it's the offset from that point until the end of that ring, of that polygon. So it's really just minimizing the amount of data that we have to process. We, in the client side, efficiently process and prepare those features to be drawn on the graphics cards. That involves us triangulating in an efficient way. We also do lots of line optimizations, so we can balance the display quality with overall performance. So with the symbols that you can choose from in your web maps, we have different types of line endings, and those cost more. But what we noticed is that anything less than 2.5 pixels wide, we can get away with actually using the simplified quad, which gives us the fastest processing time with just a little bit of memory being used. So important point here is that we're doing the best that we can under the hood to ensure that your visualization is fast and performant. And the performance has greatly improved throughout the year. Actually, for the last several years, you've probably noticed this as we've moved to WebGL in both the old map viewer and the new map viewer. We can see here just the performance improvements alone between March and June in the new map viewer. So on the left, we have census tracts for the continental US, somewhere in the order of 65,000 polygons, and you see how fast it's drawing in June as compared to March. And on the right side, we have icebergs around Antarctica. I think it's some 330,000 points, and you see how fast they're loading in June as compared to what it was doing in March. With WebGL, feature tiles, the CDN using protocol buffer format, compressing the data with Brotli compression, these are all capabilities that enable you to work with larger data sets at scale. All right, let's just jump and do a quick demo highlighting a little bit about the feature tiles. Okay, so I've got this item here. This is a feature service of California Historical Fire Boundaries. I think the important thing to note is that in this case, I've only shared it with the organization. Now let's look how this is used in the map viewer. So I've got my network tab open down here to kind of give you an idea for what happens under the hood once you turn this layer on. Let me zoom out one, sorry. And well, we see that we are missing from CloudFront, but we're getting feature tile cache results back. So these times are all very fast, about a half second. Let's make a change to the data. So I'm gonna go over to the data tab and make an update here. Change it back so I don't mess up the data. And we see that the data was updated at 12:13. Now let's go and zoom in one more time. And there we go. I get to the point where I haven't viewed these feature tiles before. The data is not coming from CloudFront, and it's not cached as a feature tile. So the response times are a little bit higher. The first time someone visits an area and goes to a place for the first time on your layer, no matter what application it is, they're going to take this hit. And then the next time that anybody else comes to this area, they will see it as a feature tile. So if I zoom out and zoom back in again here, I should see that all of these are now hit through feature tile requests. Let's see all these trues here. And all of these times are less than 300 milliseconds. Now we can even make this go just a little bit faster once we shared it publicly. So I'm going to share this to the public. And I just want to call out on the settings page, you will see this cache control. When a layer is shared with the public, it's cached at the CDN. So the CDN can really help you improve your performance. This is where you set what is the longest time you want your users to wait before seeing updates. The default that we set for all new services is 30 seconds. You can move that up to an hour. I really wouldn't move it to never. I would keep it always set if you're sharing it to the public. You're going to get the best performance. Even if, let's say, your data changes every 5 minutes, setting it to 5 minutes is a good practice to do. Now I've got it set to the public. I'm set for 5 minutes. Now let's navigate this application. So maybe zoom out one more time, zoom in again. Oh, sorry, I need to reload this page because since it's I was already signed in. Now that this layer is public, let's get to where we were and turn this on. Okay, zoom in one more time and zoom back out. There we go. See, now we're starting to see these hits from CloudFront for those queries. And remember, those queries coming from feature tiles were about 200 milliseconds. Now they're less than, they're around 50, 60 milliseconds. So that's kind of the order of magnitude of response times that you're going to get when working with feature layers cached at the CDN and through feature tiles. So you're going to get around 50 to 60 milliseconds per query once it's at the cached at the CDN, maybe 200 milliseconds per query if it's cached as a feature tile. And then if it's got to go all the way to the database, depending on how much data is being retrieved, you could see upwards of a second, 5 seconds, even 10 seconds to return those queries. So this is just kind of give you an idea of what's going on under the hood and to give you the confidence to share your data to the public so that it can be picked up and shared and perform really well. All right, I think with that, turn it over to Paul to talk about hosted feature layer views. Paul?
All right, thanks, Jeremy. So let's talk a little bit about hosted feature layer views, what they are, and kind of we're going to work through kind of a practical example to kind of ground the concept in kind of a real world use case. So for those of you who aren't familiar with hosted feature layer views, you create them from an existing hosted feature layer. And one of the things to really note here is that in creating a view, you're not duplicating your data. You're not incurring additional credit storage costs. All of your views point back to the same underlying data set. And it's just that you're creating a unique perspective into that data. And in doing so, it gives you a lot of flexibility to really tailor the view to meet your audience's needs. And so that could include, if you've got sensitive information you want to remove, you can either filter that by a query, or you could just hide entire fields from the view completely. Also, if you want to really focus or restrict what the user can see geographically, maybe you're making a view just for a specific area within your state or municipality, you can restrict that information geographically to and just share that information only. Speaking of sharing, each view has its own independent sharing from one another. So you can share some layers, layer views publicly. You can keep some private to your organization. They also have independent editing capabilities. So you could have a view that's read-only and shared to the public. You could have a view that is, add-only and shared to specific stakeholders, maybe within either your organization or someone else's. And then they function just like a regular feature layer at the end of the day. They just have some additional capabilities on top of them to define these rules. And one of the other really cool things that I'll touch on in the demo at the end is that through the analysis tools, if you happen to own both of the layers that you're joining together, you can opt to store that as a hosted feature layer view. And that's a dynamic join on the fly of your data set. So as those source layers update, the join updates dynamically as well. So with that, let's hop over and just dive into a quick demo. So this is a blog that I've put out a little while ago now, but it's still very, very relevant to kind of the views and the concept. And this is included in the handout sheet that's part of this webinar. So if you're looking to kind of read it in detail afterwards, you've got the link right there. But it's focused around a crowdsourcing example in Oakville, Canada. And they happen to have had, as urban boundaries expand into more rural areas, coyote habitat is being encroached on, and therefore you're getting more coyote sightings within the actual city itself. So they've made that information public from an awareness perspective. But if you wanted to kind of deploy some sort of crowdsourcing solution and also give your field staff the ability to kind of report observations in the field and have that information awareness as new data comes in, doing so without views actually requires a lot of republishing data, duplication to kind of achieve the same capabilities. And that's where views really shine. We're not duplicating data. We're looking at each individual user's requirements, and we're creating a view to meet those requirements. So when we consider the public, they kind of need to accomplish two things in this example. They need to be able to add new coyote sightings when they're out and about, and we want to encourage that. And the layer that we're going to share back out to the public for awareness is going to be read-only and only shows information that has actually been reviewed by the city staff. And so for those city staffers who are reviewing the data, we're going to create a view that's unique to them and allows them to see all of the sightings that are pending review. That gives them the ability to remove duplicate reports. They'll need to edit and update, and as well as kind of delete. So that gives them a focused view. And to support the city staff in the field better, we want that to encourage them to also report coyote sightings. So they need to be able to add new sightings. And because they're out in the field and it's important to have the most up-to-date information, even if it's potentially maybe a little inaccurate or hasn't been reviewed, we want them to see all of the sightings, regardless of whether the city staff has reviewed it. Because we don't want them to miss a coyote sighting just adjacent to the park they're working on just because it hasn't been reviewed by the city staff. So how would we do that and pull this all together? Well, we're going to publish 4 views at the end of the day for each kind of specific use case, one for the reviewing, one for reporting, and for the public to push information to, as well as sharing that information back out to the public. And so I've gone ahead for the time constraints and made those individual views ahead of time. You can see over here on the side. But to create a view, you just come here and create a view. You give it a new name, and after the view is created, you can set your definition. And the definition kind of defines the rules of the view, so to speak. So you can hide fields, you can filter geographically, or you can pass it a query to filter the data based on your attributes. And I just want to call out too that it's important to note that that's not like a soft filter. That we have filters on the map that individuals can remove and see the full data set. This is strictly enforced all the way back to the REST endpoint on the service. And if you're exporting the data, it's applied on the export as well. So it's a very strict filter from a security standpoint. So I'm just going to hop into a couple of views and walk through how you kind of configure these. So the first one I'm going to look at is the public-facing survey. So I've created this view. You can see that I've shared it to the public so that everyone can access it. And this kind of summarizes the goals here. We don't really care about symbology because based on our configuration, they're never going to see dots on a map in this particular app. They're only going to be pushing data in. And the way that we achieve that is by going to the editing settings. And so this is a view, and even though the parent feature layer is fully editable, this view has editing. Users can only add information. And even though they can add information, they actually can't see the information after they add. And that's kind of how we achieve that, help achieve them seeing unverified reports in this particular layer. And then we'll talk about the viewing layer as well. So to set a definition, you can either go to the visualization tab on your view, or you can add it to a map and update it there. And I just want to call out, this is the filter that is the soft filter that I was talking about that users can remove. That is not the same as setting a definition, and that sometimes trips people up because they're very similar. What you want to do is go to more options and set view definition. And you can define features. So if we were looking at this one, it doesn't have a filter set because users can't see any of the data anyways. I can see this data here just because I'm the owner. I've also gone ahead and through defined fields, I've turned off access to fields that are internal to the organization. So, the public generally doesn't need to know anything about who the data reviewer is or our own internal IDs to manage that. So that's the survey case. So now I can add that to my crowdsourcing app, and that'll allow users, public users, to push that data in anonymously to be vetted by the staff. And I've set the data model up so that the default status on kind of whether it's been reviewed or not is pending. So if we hop over to the data reviewer side, we'll see that we've kind of tailored that view to meet their needs too. So we have full editing enabled. We can see that here because they need to be able to do just about everything when reviewing that data. And if we go over to the visualization tab here and look at the definition quick, we'll see that we focused this view just showing the pending results. So, the data reviewer only cares about what hasn't been reviewed. So there's, they don't need to worry too much about data that's already been through the review process. So we filtered that, focused, so that they don't have to kind of traverse and can easily identify what they need to do. So once the data has been collected from the crowdsourcing app, it's been reviewed by the staff, we need to push it out to the public. And to do that, we've created a view that is read-only. So if we go over to the settings here, we have no editing enabled. We'll see that that cache setting is set to 30 seconds, like Jeremy was talking about. So that gives us, the better ability to scale and be performant when this app becomes really popular. And if we were to look at the definition here, you'll see that we're still hiding our internal fields to the organization because they're still not relevant to the public. Additionally, what we're doing is adding another filter too, where we're only showing sightings that have been verified. So the public only sees the sightings that have been reviewed by the staff and then pushed back out through this view. And if we wanted to, say there was a special event coming up and we wanted to restrict it geographically, I'm just going to show that the same menu is available in the map viewer as well. So I can define an area of interest. And so maybe there's an event at the golf club right here. And if I hit apply, what this is going to do is restrict that information geographically. So I could go one step further and really create event-specific views from a health and safety perspective, still while managing my data set as one citywide data set. So the last one that I have here is really about the field staff. And so the field staff, they have full access to the data, but they can only add. We don't need them deleting or reviewing things. So I've just tailored this so that they can push data in as they see it in the field, but they also have viewing access to everything. So that's kind of the core view workflow. So it gives you that flexibility to control sharing, editing, what the data definition is for each individual audience, all while maintaining a single data set behind the scenes for you to make your life easier. And last, I want to quickly show the join. So the join's pretty cool. What I've got here is countries from around the world, and I've got poverty statistics that show % below the poverty line for various countries. I'll just take a minute to show up there. So I've gone through and joined this already, but to get to this, the end result here, what you would do is go through the analysis tools. You'd pick your layers, you'd do an attribute-based join, and down at the bottom here, if you happen to own both layers, you can optionally store this as a hosted feature layer view as opposed to a completely new data or layer which duplicates the data and is then disconnected from the underlying data sets. So because it's dynamic, I can turn on this layer and I can actually edit the underlying data. So I've got a refresh interval here that's refreshing this. And what I'm going to do is come over to the table of poverty statistics, and I'm going to quickly change Canada. So Canada is now 70% of it's below the poverty line. And you're going to see this data refresh a few times. And this is the cache that Jeremy's talking about and how long, when we say how long users might wait to see edits. So I made a change to the data. The cache age on this is 30 seconds. So as this data set refreshes, we should see Canada light up and turn dark blue. And there you go. And you'll notice if you were paying close attention that that actual refresh that turned it light blue is slower than kind of the previous refreshes. And that's because it's no longer pulling from the cache. So right now it's refreshing, it's pulling from the cache. And so we get that performance benefit. But that initial kind of reload of the data, it's a little bit slower, and then it speeds right back up for everybody else. And I think that's it for me. I'll turn it back over to Chris.
Great, thanks, Paul. So data management is another key aspect of working with your hosted feature layers in ArcGIS Online. As Jeremy and Paul were going through their demos, they kind of touched on key data management aspects of things you want to consider, or a decision-making point, whether it was like the CDN response time that Jeremy showed, or whether it was setting the view definition and hiding sensitive fields, or just the fact that you can create a read-only view like Paul showed. In ArcGIS Online, data management is broken down into 3 general buckets. First is like schema, the schema for the data in your layer, the fields, domains, the information about your fields, like field value types. In ArcGIS Online, you can configure and manage those. Access, who can access your data, who can edit, and that ties into the view definitions, setting or creating feature layer views. And then also bulk updates. You can update through a web editing application, through something like Collector where you're syncing back updates, or you can do a full bulk update to where you're doing append to update data in place, or appending new data, or doing something like Calculate, or even a collaboration between enterprise and online. So let's do all these bulk updates a little bit more. So for those of you that have published from desktop, I'm sure you're familiar with the publish and overwrite workflow. It's one of the popular strategies for doing bulk updates, but for all these, there's some benefits and some trade-offs. For overwrite, the layer is deleted and recreated with the same item ID as well as the same URL. But the data is not available during the downtime. So if you have a large layer and you're performing overwrite, that downtime can sometimes be a little bit more significant. Append, your data is live during the update, so it's never not available. You can add features or add additional records, or you can update the features in place. The data is live, but it does not support delete, so you can't delete features, so there's a limitation there as well. The ability to include attachments as part of append is coming, and you also can't make any schema changes. And if you have enterprise, it offers another powerful way to get updates into ArcGIS Online, or even between enterprise environments. You can collect data using your enterprise infrastructure, and then make those updates available in ArcGIS Online, allowing you to kind of leverage the full scalability and caching infrastructure of ArcGIS Online to make data available to the public. And with that, let's dive into a demo. All right, so rather than drill through a couple couple workflows, what I wanted to do was touch on a few different data management aspects in ArcGIS Online and kind of talk through them a little bit. And to start with, you need a hosted feature layer. And I'm sure many of you have already published one. You can come from a source file like a shapefile, a CSV, Excel spreadsheet, a Google Drive, or publish from desktop. Another way you can create feature layers is to create an empty layer, so there's no data inside of it. And you can do that from the create option in My Content. And there you have a few different options. You have the template option, and we'll get back to that in just a second. You can also create from an existing layer organization, or from a URL to a feature service, which may not be actually a hosted layer at all. So that's a good way to import a schema from somewhere else. ArcGIS Online, though, offers a rich set of industry-specific templates to get you going. And for our purposes today, we're going to do a hydrants inspection template. This template includes 2 layers. One is a hydrants feature layer, and then the related inspection table. If you're going out in the field with collector to capture data, you can enable a GPS receiver option, and that will then capture metadata about the GPS, so you can perform QA, QC later on back in the office if you need. We can complete this out, but I have another layer ready to go in the interest of time. So, so now I have a created hydrant inspections layer created from the template, and you can see that I have the hydrants feature layer and the related inspection table. And I'm going to cruise over to the data tab. And again, you can see you can drop down between each option. And now you see what we get. We have an empty hosted feature layer I just created from the table. And then now we can do a few things here. We can start modifying the schema, or we can immediately load data. And I'll get to the schema modification in a second, but I want to go ahead and load some data. So to get started, I want to bring in the location I have for hydrants already to start collecting a new round of inspections, a new cycle of inspections, or what have you. All right, so I have my CSV uploaded, and what I want to show you here is that we're going to add new features. We don't have any existing features to update, and there's already some field matching that goes into place that tries to match up fields between the hosted feature layer and the CSV or the data that you're bringing in. For example, manufacturer, and then location fields like latitude and longitude. Now, none of the other fields match, but we can match them up manually if we need to. In this case, I know that my work order ID is actually, it was related to the hydrant ID, and that's what I want to use for the facility ID. And so we can do an update real quick with that. And now we have 300 features immediately appended it, and this layer is really kind of ready to go to capture edits if you need. But maybe the schema isn't exactly what you need. You can start off with doing things like deleting fields. If you have, if you need to populate the records in the table for a particular attribute, you can do calculations based on the values that you added. So maybe there's a date that you need to calculate. When you do calculate, there are two options: Arcade and SQL. SQL is ideal for larger data sets. It's a server-side computation. You can use it with sync or keep track of created features. Arcade is ideal for lighter data sets. It has improved troubleshooting, but you can't use it with sync or keep track of created and updated features enabled. All right, so now we're talking about modifying the schema for these layers. We can do a few different things with fields and actually, get more information about the specific fields. You can add a field from here. And what I want to do though is I want to drill into the manufacturer field. If you recall, that's the field that I just included as part of the append operation. And a few things here. You can update the field alias, like for the facility IDs. If that didn't really match what I wanted to do, I could change that to my hydrant IDs. The field description and the field value type, you can set these to where, like in this case, name and title is perfect as the name of the manufacturer. You provide a description as well, and these aren't widely used across ArcGIS apps, but over time you'll see it used more. Map Viewer Beta uses it now, and it will help make informed decisions about, or help the app make informed decisions about what your data represents. You can do additional things. You could set unique, you can enforce uniqueness on the field. And so say with those hydrant IDs that each one would have a unique ID. And so you can enforce that here. So as part of the edit operation, that nobody's gonna ever enter in duplicate IDs. Specifically though, in this case, I have a list of coded value domains. These are not the actual ones that were brought in as part of the append data for the manufacturer field. These were provided by the template, and they don't actually match my data. So I want to delete this entire list. Now, that's done. I can come back and I can generate a list from the data itself, from the field, from the attribute values and the manufacturer's field. And you can see that along with the coded values generated, that it includes a count for each one. All right, so a lot of powerful things you can do for configuring your schema, and hopefully some of these kind of things work. You kind of have an idea for how you can bring them into your workflows. One other thing I want to show you right here with this, and this is what Jeremy and Paul have already touched on, but it's worth kind of mentioning again, is that on the feature layer settings tab, all the editing options. A lot of times these will be already preset for you as part of whatever application you're working with that creates these layers, or maybe through some other workflow, but it's worthwhile being familiar with these just to make sure that editing is configured as it should be. For publicly editable layers, you really don't need to have delete and update unless that is really a purposeful thing, because that would mean that anonymous users could potentially modify data submitted by other people, and that's usually never a good idea. So you wouldn't want to keep it locked down to add, like Paul showed for the crowdsourcing. And further, you have additional controls like enabling export, managing spatial indices, and setting the cache control setting like Jeremy showed. All right, so switching gears a moment, I want to talk about and show you something that was introduced in the ArcGIS Online release for the UC. Maybe some of you have already noticed this. So hosted feature layers are comprised of one or more layers, and we call those sublayers, and they're not really surfaced very well when you search for something. A lot of times you'll find a hit, but you may not find out exactly what you're looking for the sublayers actually within the hosted feature layer item. So we're trying to surface that more in the UI, and you can see with this hosted layer item I have here, it's composed of a dozen layers or so. And immediately you can get a sense of the geometry associated with each one, and you can then drill into them. And as the owner of the layer, you can provide summary, description, credits, etc. And then those are then eventually will be some part of a search experience that you would then be able to discover specifically like international airports or California airports. Some of the things from the main layer page, we've moved to the individual page like attachments. You can still do things like append. You can do things like export, and it's just targeted the individual sublayer you're working with. But one of the coolest things, though, is that you can create a feature layer view from the primary data set with multiple layers where the view only has one layer. So that's a really cool, powerful workflow, similar to the view definition workflow Paul showed for hiding individual fields or specific data. You can also take it where you don't even have specific layers in your public view. So it really gives you a lot of control in thinking of how you want to create additional layers from your primary layer. And with that, I believe back to the slides and a couple of things to wrap up with real quick. So we've mentioned this a few times, but it's worth really reiterating. When you're sharing a layer to the public, to take advantage of ArcGIS Online's caching infrastructure, as well as protecting the integrity of your data, there's just a few key points. First is to use a read-only view when sharing to the public. So like the editing settings that we just showed, make sure those are disabled for your layers that are shared to the public. If there's an edit workflow that makes sense for the public that you're trying to achieve, make sure to use a view layer that has add only, so folks can't modify or delete data that you have in your layer. And then finally, depending on how often your data is updated, set the cache age accordingly, as Jeremy mentioned. So if your data is updated every 5 minutes, consider at least a 5-minute CDN time. If your data is updated every hour, consider an hour, and that will generate a pretty significant improvement for how your layer performs. And that's it, really. That's all.
Great.
Yeah, to double stress that, Chris, I think you're absolutely right. Be really careful about sharing your data public with editing turned on. It's harder to scale. It's not as performant because we actually download the source geometry without any generalization. So it's not going to work very well. It opens you up to having your data corrupted by nefarious users in the public. And if you have something that goes viral with an editable layer, you'll probably be getting an email or a phone call from Mary Ann.
No one wants that. Thank you. And thanks everyone for your presentations and the questions. Everyone, thank you so much. We have loads of them. So we'll turn to those now so that we can answer as many as possible while we've got you on the line. But a quick reminder that this was all recorded and we will send those recordings to you via email. And we do have the links for you as well in the handout. So hopefully we're giving you the path to catch up on anything that you may have missed. So with that said, our first question let's talk about rebuilding spatial indices. When do we know that it's time to use that function? How often do we rebuild spatial indices on a feature layer?
You know, in theory, you shouldn't have to use it at all. We should have processes as your data changes and goes outside the extent that it would rebuild it. I think a good rule of thumb is if you've got some queries that aren't performing very well for whatever reason, give that a shot. It won't hurt it. That might be the issue. I don't know, Chris, Paul, you want to add anything to that?
No, nothing really to add. But yeah, no, the one time where you may want, and it doesn't happen very often, is when, yeah, you publish your data with a really small geographic area and that like expands over time.
Yeah.
Periodically, you can there's some benefit to updating those indexes from time to time as that data expands.
We should be doing that automatically. So if you've got a reproducible case, be sure to submit it to support so that we can get it.
Good advice. Thank you. Next question, we have an attendee who is regularly using Truncate to update the hosted feature layers, in fact, every day. Is this a good approach for updating these layers?
It can be. I think a couple of things to sort of watch out for is when you use Truncate, that removes all the data. So until you put new data in, your layer will be not returning any features. So that's one thing to sort of keep in mind. It will, if you did it a ton, it may cause some funky issues based on object ID reuse, but probably you won't run into that. We are looking for a better way to allow you to have a publicly viewable layer, a view, and then allow you to swivel that view to another hosted layer. That would allow you to create a second data set where you can do your QA, and then when you're happy with it, you can point that public view to that new hosted layer. That way the public doesn't see any time, and it does give you the ability to QA, QC what you put up there. So we're looking to try to do that, expose that in the experience later this year or early next year.
Thank you. Next question, on the topic of, I think, the caching and the CDN use, what happens if you clear your browser cache every time you close it and every time you open it?
Yeah, if you clear your browser cache, then yeah, you won't leverage that any browser cache that you might have done. But since we have caching at multiple tiers at the CDN, and then also within ArcGIS Online's feature tile cache, those will get picked up. So you won't really see much impact. The way it works is that cache setting that you set, so 30 seconds, let's say, that's going to set the cache setting at the CDN and also at the browser. And so what it means is once you've loaded that layer in the browser, if you make that same query within 30 seconds, the browser won't even go back to the server. After 30 seconds, it will go back and ask, hey, I've got something in my cache, is this still good? And either the CDN or ArcGIS Online will respond with, yeah, it is still good, or no, here's the real data. And that's kind of how that works under the hood. So yeah, shouldn't be a big deal.
Yeah, and what's the advantage of CDN?
The CDN really pushes your data to nodes around the world, wherever it's being requested. So if, let's say in Australia, and you are you've got a hosted feature layer, you don't want that data traveling from the US for every request, because you're going to have some network latency problems. And so what the CDN allows you to do for that public data and populate the content delivery nodes in the Australia region, so that when users in the Australia region come through, they'll go to that node first and get the data. We also, we just introduced this past UC, the ability to have this might have been in March actually, new organizations where the hosted data is in Europe, and in this case, Ireland. So we're looking to also expand that as we go. So that'll improve the performance for private data.
Great, thank you. Our next question is, why does the visualization tab on the hosted feature layer item details pages, why don't they draw all the features? So I can say that again if you didn't catch that.
No, yeah.
I think something. I think this was for on-prem versus enterprise. I mean, for online. Is that right, Marianne?
Let's take a look. Let me read the full question. Shouldn't it be able to retrieve data in chunks or tiles like apps can? Actually, I may be confusing older versions of Enterprise with ArcGIS Online. So it sounds like the attendee it has been using a lot of different ArcGIS products, which I think we can all empathize with. There are a lot of things to keep track of over the years. So the question again, I'm not sure if it's specific to Enterprise or Online, but it's why does the visualization tab on the items details page not draw all the features?
Well, one reason is that that app that is in that visualization tab is actually the old Map Viewer or Map Viewer Classic, and it can't draw as many we don't request as many features as new Map Viewer or other 4x JavaScript API-based applications. So you will see some slight differences in the number of features it gets. It's still WebGL, it's still leveraging feature tiles, but you may not get any features. So that can happen. The other point to call out is that feature tiles are not currently in Enterprise. They are targeting hosted feature services at 10.9 to have some feature tiles. So then on your enterprise-based applications, you would be able to leverage that feature tile and hopefully be able to connect up a CD to your enterprise as well.
Yeah, that's helpful. Thank you. The next question is an important one that we hear a lot. Can feature layer views be made public without making the underlying feature layer public?
Yeah, I can take this one. Yeah, totally. So the views editing capabilities are completely independent from the underlying source. So you could have the source read only and any view with any configuration. The one thing to note there is things like sync. If you want to use that data offline, the parent does have to have sync enabled for the views to have sync enabled as well. But you can disable sync on a view if the parent has it. So.
Great, thank you. What is the difference between normal filter and view filter?
Great question. I tried to call that out earlier in the talk, but with my issues, it might have got lost. The normal filter that you do in a web map or on a layer is what I would say a soft filter. So if I published that map and gave it to Chris or Jeremy, they could remove that filter and then see all of the data, that unfiltered data. With a view, setting that view definition for defined features is strictly enforced on all queries. So they can't remove that filter and see all the data. So it really comes down to security and access.
Thank you. Next question, is it possible to define an area of interest based on another feature layer?
I mean, technically, yes. If you were writing your own custom app, it is something we want to expose in a future update. We're just playing around and trying to figure out the right experience to do that. Yeah, you should see that come in the future. It is something we want to do. You know, as a developer in Python, you could do that today, but through the core website, that'll hopefully be coming in the future.
Cool, thank you. Next question, I love this question. Is it safe to say that a feature layer view is similar in general, conceptually, to a database view in an enterprise geodatabase?
They are quite similar at the end of the day. It's a valid way to think of them. They might have, you know, slightly different implementations under the hood, but they kind of aim to achieve very similar goals.
Right.
Under the hood, we are actually using database views. So, yeah.
Cool. That's a great nugget, a little factoid for us. Thank you. Are the view options also available in Enterprise? And if so, from what version?
I think I'd have to fact check that in the documentation. So, but to be safe, I'll say the basic views, I believe, were available as of 10.7 and up. And that includes being able to define features, fields, and an area of interest. The join, I believe, is still pending in Enterprise, and that will hopefully be coming in the next release or two.
Okay, great, thank you.
Because this came up in the, sorry, Marianne, because this came up in the session. Chris, do you want to talk about the differences with append?
Sure. So, Paul, I forget, is append exposed at all? Is it only exposed as append, or is it not there yet?
Append is coming. Yeah, append is coming. The Enterprise team has been working really hard to support that, but I think it's targeted for the next release.
Okay. If arcade code can't be applied to hosted feature classes where sync is enabled, is there a timeline when it will be?
I think that's referencing specifically the field calculate. It is a restriction that we want to remove. Right now, in the future, we're looking to kind of remove that restriction. So hopefully before too long, we'll be able to do it. I don't know, Jeremy, if you've got anything else to add?
I mean, not directly related to that, but Enterprise feature services allow you to set up attribute rules on the server, and those rules are driven by Arcade. So you can set up like hey, I want to calculate something anytime something changes on this feature. I want to set some kind of constraint. I can't go in here if it's bigger than this, or I want to validate it. And that dev work is happening, within the hosted feature services of ArcGIS Online. So we'll eventually have similar capabilities in ArcGIS Online that you have on Enterprise feature services with regards to attribute rules, where we have Arcade running on the server. So look for that in the next six to 9 months.
Great, thank you. And with that, we have just under a minute left, so I'd like to take this opportunity to remind everyone that this webinar and Q&A is being recorded, and we will email that to you in the next 2 weeks. We have a handout for you as well that has lots of handy links that cover all of the topics that we got into today. And of course, as always, there's GeoNet, which is community.esri.com. And we have support always available, standing by. So please stay in touch, and thank you again so much for joining us today, and thank you to our presenters as well.